Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, thank you for watching IT Pro TV, helping you level up with IT learning everywhere you go. I'm Zach Memis, your host for this episode of CompTIA Linux Plus. And in this episode, managing services with System D. And we've asked our expert, Don Bizet, to tell us more. Don, good to see you. Thank you for being here.
Glad to be here, Zach. I'm ready to dive into the world of System D, which is a really powerful new technology. I'm going to say new. It's actually been around since, I think, 2008, but really gained prominence in the last 5 to 6 years. It is responsible for powering the majority of Linux distros that are out there. So really important that we need to learn how it works, what it does, and because everything it's doing is behind the scenes. So in this episode, what we're going to do is kind of pull back the curtain and get a chance to see exactly what System D is like, how it functions, and how we can interact with it to keep our system up and running and make sure our services are operating properly.
Well, how are services controlled under Linux?
So, there's a few different ways this stuff can be controlled, and we're going to focus on System D, but it's not the only way. So there's many systems that use the original Unix init system. So, when Linux boots up, there's a kernel, right? And the Linux kernel gets called. That's really important. That's the part that Linus Torvalds wrote. But the kernel itself doesn't interact with the user much. It's kind of limited in what it can do. So it's actually, I don't want to say it's not impressive, but from a standpoint of computer technology, it's very impressive. But from a standpoint of human interaction, it's not very impressive at all. So what the kernel does is, as soon as it fires up, the next thing that it does is it launches what's called an init process, right? And the init process is what actually starts all the various services and makes your operating system work. It seems super impressive to us, but technologically, it's really basic. In fact, in the original versions of Unix, they used what was just called the sysv init. The sysv is System 5, was for tracking one of their releases. And the sysv init, what it would do is it just had a folder with a bunch of scripts in it. And it would run the scripts one after the other, and that would start your system up. And then when you got to a login prompt, it was because at some stage, a script was run that launched a shell or a console and then made that available to you. That's all it was, right? Well, that sounds really simple because it was really simple. And it had certain drawbacks, certain problems, certain things that made it not efficient. The number one problem was that sysv init ran everything in a serial order, one after the other. So it would run script 1, then script 2, then script 3. And if script 3 took a long time or if it hung, the system just waited right there, right? So it wasn't terribly fast. So that was one problem that it had. The other problem was that the scripts were just run when the system booted up, right? And after that, if something changed on the system, the scripts wouldn't detect it unless you recalled them. That wasn't a problem back in the 1970s and in the 1980s. But fast forward to 2019, where we are constantly adding and removing hardware from our systems. You might have USB thumb drives or webcams or whatever that plug in and go. Imagine if you plugged in a USB key and the system didn't even know that happened. Right? And we had to run these scripts and tell it to look for that missing hardware. So that is a problem with sysv init. System D was created as the next generation of that to try and replace sysv init and do it in a different way. So what System D does is it's not just a series of scripts. System D is an actual program. It's an actual daemon. It actually stands for System Daemon. And if you've never heard that term, it's DAEMON, daemon. And in the Unix and Linux world, any program that runs in the background as part of the operating system that runs unattended from the user is called a daemon. It's just doing its little job in the background. It actually comes from a physics book that described some weird physical motion. It's a crazy history.
Some other book.
Yeah, but basically, these daemons are what the system is running in the background, and it used to be the init scripts that would call them. Now it's the System D executable. So this program runs. And it doesn't just run when the system boots up, it stays running. So System D stays running the whole time your system is online. And it's able to do things like, well, one, it can detect hardware changes because it's always running. Two, it can do things in parallel. It can say, all right, I'm going to run these 5 routines all at the same time. And if one hangs, it's no big deal because I'm still doing the other 4. And so it's faster, right? System D is faster, more stable. There are some people out there that don't like System D. You'll hear some people complain about it from time to time, because it moves away from tradition, right? Traditionally, you could control your entire Unix-like operating system by modifying some text files. With System D, it's not like that. It does have configuration files, but it's actually doing a lot of stuff in a binary. And some people, if you're like a Unix purist, that's not something you're happy about. But I'll tell you, as a Linux administrator myself, I love it. I think it's faster. It works really well, and it's a great way to deal things. So, systemd is pretty prominent, and it's typically how we're going to be manipulating services. So, going back to Zach's original question, hey, how are these services controlled? You power on your system, right? Your BIOS kicks in, it reaches out to the hard drive, it finds the boot files, loads up that Linux kernel. Then the Linux kernel launches a init. And in this case, it would be the systemd that it fires up. And then systemd goes through the routine of starting everything else that you need to interact with your system and bring it online if it's supposed to, right? If there's things that aren't supposed to come online, it leaves them off. Systemd is what's actually controlling that.
So how do we know if we are actually using systemd?
All right. So, good question. I will say that all of the major Linux distros these days use systemd. So if you get Ubuntu, if you get Red Hat Enterprise Linux, CentOS, Fedora, Mint, the list goes on and on. All of the major distros use systemd by default. So the odds are you are using systemd. But it's not 100%. There are some distros out there that have chosen not to go with systemd, that are following the old model, the sysv init. Or there was actually another init system called Upstart. Upstart was really just a slight modification of sysv init. It wasn't a full-on like change. So you may find some systems that do that. Typically, it's if you're running older versions. Like if you're running CentOS 7, you're using systemd. But if you're running CentOS 6, you're using Upstart. And if you're running CentOS 5, you're running sysv init, right? So, it's kind of changed over time. If you're running Ubuntu, they've been running systemd for the last 3 or 4 versions, I think. And then before that, they were on sysv init. But there are current distros like Slackware. Slackware was actually the very first Linux distro that I ran back in 1993, 1992, I think 1993. Either way, it ran sysv init back then, and it runs sysv init today. They have not moved over to systemd because they follow that model of a pure Unix type deployment. There's other ones. There's variants of Debian. I think there's one that's called Devlon that actually uses sysv init instead of systemd. But none of the major distros. So if you're deploying something in a business, if you're deploying something where you need support, all of those companies are using systemd. But we can verify, right? Let's be sure, right? So I've got a CentOS box here in front of me, and I'm running CentOS 7, and I know that it defaults to systemd. I shouldn't say default, like it just runs systemd. But if we want to verify that, there's a few different ways. I mentioned the boot order earlier, and when I turn the computer on, the kernel fires up, and the first thing it does is it starts init, right? So technically, your init process is the very first process that runs. It's number 1. So if we use a utility like PS, right? This is the process show command. It shows me all the processes running in the background. If I do a PS AUX, right? That says show all of the processes with the user that's attached to them. And X, I can't remember what X does. It's like a services or something. I can't remember what X is. But if I do PS AUX and I run that, it will show me all the processes that are running. And if you look at these process numbers, right? It's this second column. I've got process 13,999, process 14,416. When a process runs, it gets a number. And when it closes, the number goes away. And it just kind of keeps incrementing and growing. So over 14,000 processes have run since I booted this machine up.
Yeah, it's a couple.
Which hasn't been up that long, right? I've been up for an hour and a half. And so that's a big number. But if I scroll up on that list, let's just scroll. The numbers get smaller and smaller. These are processes that ran early on and are still running. And I can find process number 1 right there, PID number 1. And if I look to the side over here, it's /usr/lib/systemd/systemd. That tells me that I'm running systemd. I'm on CentOS. Let me jump over to Ubuntu. So this is an Ubuntu machine, and I can do the exact same thing here. If I jump into my terminal, and I'll just do PS AUX, and I'm just going to feed it into the head command, save a little time. And there's my process ID 1, and I can see, oh, this one's actually a little interesting. It's telling me /sbin/init. All right, now wait a minute. I said this defaulted to systemd. That's not systemd. If you see /sbin/init, that's sysv init. Okay. However, if I relied on this, I might get tricked. And let me show you what I mean, because I'm I'm like 99.9% positive this should be systemd. I didn't check before the show, so that's my fault. But if you pull up a listing, I'm going to do an ls-l of /sbin. I want to see the binaries that are in that file or in that folder. Okay. And I go in here and find init. Actually, let me just do /sbin/init. There we go. They're tricking us, right? It's a symlink. They have symlinked /sbin/init does exist, and it's being pointed to /lib/systemd/systemd. So there we go. So it looked like in the process output that we weren't. Now, that means that we can't really trust the process output, can we? The PSAUX, it works if we're full on running systemd, but it could trick us with older stuff. But if we actually look at /sbin/init, it's in the official standard that any operating system that's using the Linux kernel has to have a file in /sbin/init. Even if it's not what's called, it has to be there. And so that's a more reliable way to look and see what we're running. If I jump back over to my CentOS box and do the same thing in /sbin, I'm going to look for, so I'm running ls-l to get a long output, /sbin/init, and I can see they've linked it there as well. The difference is in the process command, that PSAUX. On CentOS, it's actually showing me the true binary. On Ubuntu, they're showing me the link instead of the binary. So they've changed the way that command works. But I can see here they're both clearly running sbin. Now, systemd. Now, if I looked in here and it actually said /sbin/init and it was green and that was that, then I'm running sysvinit or upstart. Upstart I mentioned was like an upgrade to sysvinit, not a like a true change. So it would be /sbin/init as well. So I wouldn't be able to tell the difference between upstart and sysvinit, but that doesn't matter for us. I know we're running systemd.
So systemd starts right after the kernel, right?
Yeah,
And
yeah.
then what happens?
So it's a big deal, right?
Yeah,
It's the first thing. And if systemd crashes, your system crashed, right? It's powering everything.
Mhm.
So once it fires up, then it's got to get to work. And it says, okay, now it's time for me to do my job. I need to start some services. I need to open up some ports on the system for network communication. I need to figure out whether we're going to load a GUI or go straight to the command line. It has to do all these different things. And it does that through the use of unit files, all right? Unit files are stored in, if I change directories here, I'm going to go into /lib/systemd/system, all right? If you go into that folder right there and pull up a listing, what you're going to find is a ton of files. And each file will be a name, and then it'll end in .service or .timer, .target, .slice. Each one is kind of something different. Most of them are .service, right? Those .service files are identifying daemons. Daemons that are going to run in the background. Those are services or applications that run and just keep running and do the thing, all right? Other ones, though, like .target, that's a user environment, right? So there's a .target file for if I want to have a GUI, right? It's actually, I think, called graphical something or another. It's in here. Remembering the names of these is pretty hard because there's so many. Yeah, graphical.target right there. And then there's a command line one, which is actually called multi-user.target. There's several others that are like that. You'll also find .socket, which is identifying a network port that's going to be opened or possibly a name pipe or something that'll allow an application to talk to another application via network service. Let's see, that was targets, services, and sockets. Those are the most common. You also see .mount. So those are where it'll mount a hard drive partition. You still have the file system table, the /etc/fstab file, but you don't need it anymore if you don't want, because systemd can use .mount unit files to be able to specify what to reach out to. So when systemd starts, it's actually parsing all of the stuff in this directory and looking at it and saying, all right, what do I need to do? And if we pick somebody here, somebody easy, SSH. All right, so SSH, that's the secure shell daemon, and it's running by default on most Linux systems so that we can create a secure remote shell, connect in, and get a command prompt, right? So it should be starting when the system starts. If I look inside of that file, so let me just cat sshd.service. There we go. There's not a whole heck of a lot in here, right? So it starts with this blocked quote right here where it says unit. And from there, it goes on to specify information about that daemon. So I can see that this is the OpenSSH server daemon, and it has documentation, right? There's a man file that's available for it, so it's got that registered here. And then it's saying, we want to start it, but don't start it right away. you need to make sure that the network.target environment has started, right? We have to have networking working before we can start SSH. And we need the SSHD keygen service running. So this is setting up a hierarchy, right? Like an order and dependencies that systemd is able to use. So it says, okay, I can't start this one first. I need to start network.target and I need to start sshd-keygen.service. So once those are started, then I can come back and start this one. And remember, it's doing all this in parallel, so it can reach out and try and do multiple things at once. And then after that, it says once, right? After it says, I can't start until these are started. But once means once I start, I want this other thing to start as well. Now, SSHD-keygen service is listed twice. And what that's saying is it needs to be started when I start. But if something goes wrong, I need that one started again because I depend on it, right? That's establishing that dependency too. So we've got those entries. And then after that, we see the actual service, right? And so it's telling me I can find my configuration in /etc/sysconfig/sshd. That's where the configuration is going to be. And then when we execute, when we start, here's the command that it runs. /user/sbin/sshd, that's an executable. -d tells it to run as a daemon, run in the background. Otherwise, when that shell closed, the application would close. We can see what to do when we close it. And it's going to run the kill command, and it's going to shut that one down. You can see how to kill it. You're just uses a process execute. It sounds really violent, but just exiting. And then restart. If there's a failure, if it crashes, it's going to try and restart it. And if it does a restart, it'll wait 42 seconds, right? This is all defined right here. When we install this service, if I want it running every time, it's going to install it and attach it to multi-user.target. So when that starts, which is our command line, when the command line starts, it's going to make sure that SSH starts as well. These are unit files, and the unit files are just text. You can actually go in and edit them if you want. It's not a great idea to edit these. Most of the time when you install the SSHD service, it creates these files for you, right? So I didn't create these. They were made for me. If I want to modify them, I usually will not modify it here because if we get an update, right? So SSHD gets an update and they update this unit file. It's going to overwrite my changes. I'm going to lose them. So if you're going to make changes, don't make them in this folder. So let me get back in here. Actually, let me zoom back out. There we go. So I'm in /lib/systemd/system. You really should never edit anything in /lib. It should just be left alone. But if you go into /etc/systemd/system, all right, and that folder might not exist. You might have to make it. On CentOS, it's there by default. So /etc/systemd/system as opposed to /lib/systemd/system. When you look in here, you'll find service files and target files and once and so on. These are where we're overriding what's done inside of systemd's folder. So if I want to make a change, I shouldn't go and change the files in /lib. I can come right in here and create a file with the same name. And when I do that, this file will override the other one. And when an update comes along, it'll leave my file alone, right? Now, I haven't overridden anything. And so everything in here was done by the system. Looks like dbus is doing some stuff. We even have sysinit, which is for backwards compatibility with sysvinit. So some of these entries are already in here. Most of these are just links. In fact, I think all of them are just links. Well, no, some of them just have weird permissions on them. But many of them are links to other locations. And you'll see them pointing to /lib or somewhere to override an activity from somewhere else. So that's how that kind of functions. And that's really the heart and soul of systemd. Systemd is a binary. It's an executable that runs. In fact, I think I browsed right past it. If I go into /lib/systemd and we look in here somewhere, right here. There we go. There's the systemd executable. It's actually not very flashy at all. It's... let me do a human readable size on this one. It's a blazing 1.6 megabytes. And yet that 1.6 megabytes is powering my entire user environment right now. The kernel is handling my hardware interaction, and then systemd is making all of my software work. I mean, this is super important software, and it's really, really small. And then it relies on all those configuration files to do its job.
Well, do we have to create unit files for new services, Don?
You can. So if I'm installing a new service, you can go in and create and define them yourself. I've had to do that on occasion, but normally the services will create them automatically, right? So let's say, let me give you an example. I want to be a web server, right? So I want to install Apache. Well, if I take a look inside of my systemd library folder, so I'm back in /lib/systemd/system. if I look for any file that starts with HTTP, oh shoot, I actually see it right there, httpd.service. So it looks like I'm already a web server. That file is defining the Apache service and getting it set up to do its job, right? Well, I didn't create that file, or at least I don't remember doing it. So when I installed HTTPD, it must have created that, right? If I were to remove HTTPD, so if I do a sudo yum remove, or we'll just remove HTTPD. There we go. So I'm going to uninstall it. So I'm uninstalling HTTPD. And now I'll just take a look again. And I see there's no unit file defined for it anymore. So when it uninstalled HTTPD, it knew to take away that unit file. And if I install it back again, so I'm just going to come in here and do an install. And when I do that, it's going to go through, it's going to do the install. There it goes. And if I take a look, I can see it created that file again, right? So most services, if you're installing them from a package file, whoever the developer is that created that software will know, hey, this is the unit file I need, and it'll go ahead and create it for you. So you really don't have to worry about it. You don't have to go in and edit these things. It just does it. Now, I will tell you, sometimes you install software and it doesn't create the unit file for you, right? And that might be software that's designed to be run on demand, okay? You need unit files for software that runs in the background, that runs automatic without interaction. I want this web server running all the time. It needs a unit file. But if I have something like OpenOffice, right? OpenOffice, I need it to run when I'm interacting with it. I don't want it running in the background. So there's not going to be a unit file for OpenOffice. Those are just user applications, all right? But sometimes when you install a service, it still doesn't create the unit file because most services don't start automatically. You've got to configure them. And we do that with systemctl. Systemctl is a utility that is packaged alongside systemd. It's the system control utility, and it lets us control systemd and do things that otherwise might require us to edit some files. So for example, if I want HTTPD to start right now, I could do sudo systemctl start HTTPD, right? And it's going to read the unit file. It's actually looking for that unit file. And I should have typed this the whole way and said httpd.service because that's the unit file name. And it's going to look for it, find it, and start it. Okay. If you leave the extension off, it looks for services first because I'm telling it to start something. And that way it doesn't look for .socket, .target, and those guys, right? But if you want, the full name would actually have .service on the end. So it's going to find it, it's going to start it. All right. Now we can start a service even if it doesn't have a unit file. If it's got dependencies, things will break. But even if it didn't have one, you could do that. But when the system reboots, that service is not going to be started by default unless we tell it. And we could go in and modify the actual service file or the unit file and actually tell it, yes, multi-user or graphical depends on this file. We need HTTPD to start, right? Or you can just do it right here with systemctl. You can say systemctl enable HTTPD, right? And when I run that, look what it did. Created a symlink from /etc/system/multi-user.target.once/httpd.service. So it put a symlink in /etc, right? And it's pointing to /user/lib/systemd/system/httpd.service. It didn't edit anything inside of /lib or /user/lib. It edited instead inside of /etc. And even then, it wasn't really an edit. It was just a link that says now, whenever I start the multi-user target, I will also start HTTPD. It did that for me. I didn't have to create unit files. I didn't have to go and modify /etc. It was just done automatically. And if I say, you know what, I want the web server, but I don't want it to start automatically, I can just come in and say disable. And when you do that, it removes the link. It didn't disable Apache. I can still run Apache. If I do sudo systemctl start HTTPD, like that, and then I can do status. So sudo systemctl status HTTPD, and it will actually show me that it's active and running right now. It's up and operational, okay? But looking up here, it says that it's loaded, but it also tells me that it's disabled, which means if I reboot, Apache's not going to be running anymore, right? If I go back and enable it again, let me do that, and then we pull that status, what I'm going to see now is that the service is enabled. So if I reboot, Apache is going to come back up and we'll be in business. So the important part here is that we do all of this without ever actually editing the file. Systemctl does it all behind the scenes for us. So this is another area where we kind of deviate away from the way that Unix used to be, where we'd edit all these script files. Now it's all automated through systemctl.
How does systemd keep track of which services to run?
So we've kind of seen that a little bit with our dependencies, but it really boils down to the target files, right? The target files are what defines what's going to get fired up and so on. So let's take a look at one of those target files. If I get, what folder am I in? I'm in the right folder, /lib/systemd/system. If I pull up a listing of star.targets, all right, you'll see a lot of targets, right? Targets are like collections of unit files. It says, hey, if I want the network to function, I've got a network target, and here's all the stuff I need for the network to function. And you'll see other things in here that are like that. You know, if I want remote encryption to work, or reboot to work, or swap files to work, they've all got different targets. And those targets are defining all the services needed to make that work. So if I want to boot to a command line, just to a command line, then I need what's in multi-user.target. If I take a look at that file, let's use less on multi-user.target, I can look in there, and it's actually not a very big file at all, right? But that's because it's including some things that it needs. It says, all right, multi-user can start whenever it wants, right? So I don't see actually I do have a require, don't I? Here's a require that says basic.target. So before multi-user can start, anything in basic.target has to start. Then this one can start. And once it starts, afterwards, we'll fire up basic.target if it isn't already, but we've got rescue.service, rescue.target. We've got a few other things that can be triggered as well to get our system up and running. Well, let's look at basic.target. So if I'll cat basic.target, and I look in here, it's also not very big at all, right? But it's got that it requires sysinit.target, and it's calling several other things too. And if I look at sysinit.target, we're kind of following this back, right? Going back, and we see how it's calling more and more things. All of this is coming together to build the environment that is required for our system to boot. If I want a graphical user interface, then I would need graphical.target, and you'll see where it depends on multi-user. The command line has to work before I can launch stuff to get the GUI, right? They all are interdependent. As a human, it would take me forever to sift through all these files and build out the tree of dependencies, but systemd does it every time you boot. It parses through these files, figures out the dependencies. It actually doesn't monitor the files on an ongoing basis. If I change a file right now, it won't recognize it unless I tell it to reload, right? So you can go in and you can reboot your system is one way to do it. Or like with a service, you use the restart command, and then it'll reload the unit file for that service. But otherwise, it's figuring out all those dependencies, kind of mapping it together. It gets pretty complex because of the sheer amount of files, but at the end of the day, they are just simple text files. You can view it all.
Well, can we change between the targets?
Oh, you can, yeah. My system right now, if I were to reboot, it's set to default to the graphical user interface. So it's basically set to boot to graphical.target, right? But if this is a server, I don't need a GUI. I might want to have the GUI installed so that when I'm sitting at the server, I can use it. But the rest of the time, I don't need a GUI run. So I could actually switch targets and tell it, hey, don't run graphical anymore, just run multi-user. And we can do that pretty easy. So here I am in my command prompt, and I could be in any prompt. It really wouldn't, or any folder. It wouldn't matter which one. I'm going to do a sudo systemctl isolate. And so I'm telling you, I want to target a specific target. That's a little redundant. And then I'll just say multi-user.target. All right. Multi-user means, yes, it's command line, but it's not just one console just for you. It still allows network services and other things to run. And so when I run that, see how my system freaked out?
Yeah.
Right? It recognized immediately, okay, we're not going to do the GUI target anymore. We're going to just do a command line. And so now I can come in and I can log in, assuming I can remember my password. And there we go. I'm not in a GUI. I'm just in the command line. And so now if I reboot, I'm going to boot just to this interface right here. This is actually, I need to go and modify my grub loader to tell it exactly what I want. But at this point, I'm now in just command line. X Windows and all the GUI stuff is not running at all. I can switch back with that same command. Well, a little bit different. So if I do sudo systemctl isolate, and then I'll do graphical.target. and that's going to switch me back. And now it's loading X Windows. See how it's taking a moment? It's not like X Windows was running in the background. It's got to relaunch all that stuff and get me in here and get me put back in place. Now, because this is happening after my boot operation and all that, you see how it's kind of like screwed up my resolution and all that. That's one of the trickier parts about moving from one to another. If something's not defined in the unit files or some other configuration file, then stuff gets lost. It cleaned up. Well, sort of. I got large icons now. So there's a lot of people like me. If you do this stuff a lot, you'll end up writing scripts to kind of automate some of the changes. And so, for example, I have a little script in my home directory. This will show you how often I do this, to manually set my resolution so that I can just run it real quick. And then I'm right back in. Now my icon's the right size and all. So you can switch between targets at the drop of a hat, but just know that there are certain penalties to it. There's certain things that happen on your system you might not expect. So definitely test it out, run through the routine a few times. But that's basically the nuts and bolts of System D right there. There's a lot more to it, but the basic operation is there's a ton of text files. It reads them and performs as they dictate.
Great episode. Managing services with System D. Wonderfully done, Don. And before we move on, what else would you like to say?
If you want to learn more about System D, definitely check out, there's a System D website. It'll be like your first Google response, I'm sure. But there's also a whole suite of other utilities. I use systemctl. There's Journal D for the special logging system that System D uses. There's hostname CTL for changing your computer hostname. There's a number of other CTL commands that are all part of what System D creates. So there's a lot more than what we went over in this episode. I was just focusing on really what's involved in getting your system up and operational and getting your services running.
Great advice as usual. Here's some more great advice. Watch every episode of CompTIA Linux Plus. You're going to be glad you did. It's going to help you now and in the future, and keep studying. Take advantage of the supplementary information in our course library. It's there to do one thing, help you be even more successful, so check that out as well. And tell everybody you know about IT Pro TV. IT Pro TV is binge-worthy. Thanks for watching. I'm Zach Memis.
And I'm Don Pizzette.
And we will see you again soon.
Thank you for watching IT Pro TV.